Hi, Kevin. How's it going?
Good. How are you, Joe?
Good, thank you. Yeah, so today we have Kevin Stumpf from Tecton joining us. For people who don't know who you are, do you want to give a quick intro?
Yeah, for sure. Nice to meet you all. I'm Kevin, co-founder and CTO of Tecton. We're a feature store company. And before having co-founded Tecton about 3 years ago, I was an engineering manager and tech lead over at Uber, where I worked on their machine learning platform called Michelangelo.
Mm, never heard of it before. I'm just kidding. It's like
Never.
only the most popular MLOps article I think ever written. So about Michelangelo. Well, great. Yeah, glad to have you on. It's definitely an honor to talk to you. I mean, how did you find yourself? Look at your history. You've been in the tech space and software engineering space for a long time, and you want to walk me through just sort of your journey to where you are today?
Yeah, for sure. How far back do you want me to go when it all started with software engineering?
Sure, or when you're born or whatever. Everyone
When I
in
was
between.
born, right? 30 years earlier than that, when my parents met. Zoom back to I started the first company after high school back in 2007, and that's when I
Nice.
still in Germany. That's where I was born and raised, and then I through that company moved over to the US, to Michigan and Detroit, out of all the places, because we were building some software for a supplier that helped GM build basically testbed automation software to help them measure the exhaust that cars and engines and whatnot produce. So that's what first brought me to the US, until in 2009, GM went bankrupt, which wasn't that much fun, but it gave me a good taste for tech entrepreneurship and whatnot. And fast forward, eventually I realized, hey, Michigan is just as cold as Germany is, which I really wanted to get away from. So why not go to California? And went to grad school in the Bay Area. And then while I was there, started another company, this time more product focused, which was called Dispatcher, and a two-sided marketplace for long-haul truck drivers, where we were sending truckers across the US, thousands of them every month, and basically made it super easy to them on an app. Just find a load, request it, book it, and then make some money through the platform. And in 2016, we then joined Uber. Uber was building out its Uber Freight division, and so our team entirely joined that effort. And at that time, I was happy to be able to spend more time on deeper tech problems and not be as deep in the weeds of hands-on operations of having truck drivers drive across the US, which was a ton of fun, but my heart beats a bit more highly for deep tech problems. And right around that time, Uber was quite heavily investing in its machine learning efforts, Michelangelo, to really streamline the process to develop and deploy machine learning, because there were just tons and tons of applications for it at Uber around, dynamic pricing and recommendation systems for Uber Eats, and fraud prediction, support on the customer support side, and just really countless different examples. But it was always a gigantic pain to productionize ML. Lots of teams had to work together, lots of handoffs, and it would take months typically to get anything into production, and it wasn't really standardized. And so the next person that had to take over a project was typically not in for a treat anymore. And so Michelangelo was really there to standardize and centralize that entire effort, and then bring down the time to develop and deploy a model to an order of minutes, or at most hours. And that's what I did until late 2018, when we decided to leave Uber and focus on a specific sub-problem of the ML lifecycle, which are all the problems around data. Because what we realized with Michelangelo was you can really split this ML platform into almost two halves. You've got on the one side the modeling layer that's concerned with the training of a model, the back testing of it, the management of the metadata, the deployment of it, and the monitoring of the predictions. And then you've got another layer, which is the data layer, that turns raw data into features, and then hands those features to your training algorithm, and then later on in production, hands those features again to your model that's actually running in production. And we realized that this data layer is really missing in the broader ecosystem, and lots of enterprises reached out to us and they said, hey, Michelangelo looks super cool, can you bring this to us too? And we looked a bit deeper into, hey, what does the ecosystem already provide? What does it not? And that's how we then circled in on the data area and came out with Tecton to solve them.
That's really cool. Yeah, I think the Michelangelo blog post, I mean, that shook up a lot of people, I would say. I think that was the first time I think I started hearing my friends talk about productionizing machine learning. I think before then it was all about just doing, like, dorking around in notebooks, you know, calling that machine learning. Half of them, I would say most of them never saw the light of day, frankly. But I think because what you guys addressed was a pretty big problem that people were, I think, sort of sidestepping around in a lot of cases, just because it's like, well, that's hard. We'll just not do that at all. So, and it always, I had the question too, like, well, are they going to, like, open source this, or what's the deal? Because it seems awesome, but all I have is an article. But that, I mean, how did you walk me through this? Because it seems like, I talked to people at other companies, whether it's Amazon or Google, about their early machine learning efforts, and it seems like it's never a one size fits all solution when you're talking about, a company like Uber, for example, which is very different from Amazon in a lot of ways. It seemed like productionizing machine learning was sort of a cold start problem for all these different companies and their efforts, right? And can you walk me through, like, how you realized, I guess, the different aspects of productionizing machine learning with this platform at Uber?
And what do you mean specifically there?
Well, I mean, like, what were some of the, was there anything you could reach to for inspiration out there in terms of white papers or articles or talking with other people? And I guess how much of that was really driven by, we have very specific problems that nobody's been able to solve before. Like, we have to figure this out.
Yeah, I mean, a lot of inspiration, honestly, with these types of platforms comes from DevOps for software engineering. When you look at how has the software engineering process evolved over the last decade or two, it's really moved a lot from the old waterfall model with a lot of handoffs to a much more streamlined process today, which we typically call DevOps, where you've got a software engineer or own the development and the deployment of a software application end to end, where all they have to do is create a pull request with where they change a couple lines of code. Then they get a coworker to review it. That pull request gets merged in, and then you've got the whole machinery being kicked off. And that whole machinery then runs your unit tests first, builds the Docker container, runs integration tests, and then throws everything over the fence to Kubernetes, where it maybe runs a canary rollout. Then it looks at some shadow traffic health metrics to see how is this new software package performing. Do I need to roll it back automatically or not? And if things look healthy for a little while, then let's just go all in and deploy the thing to all the different clusters. And it's really powerful machinery and tooling that's automating a lot of processes that just makes it finally possible for software engineers to develop and deploy software applications pretty autonomously. And I saw this at Uber, where individual software engineers with very little experience, fresh out of college, like, they'd be able to literally affect every single driver and rider by submitting a change to a line of code, pretty much just with one other person reviewing it, which is incredible and makes everybody way more efficient and really speeds up this iteration life cycle. And that's what we wanted to recreate for machine learning too, just make it similarly easy to develop and deploy an ML application. And because at the end of the day, with machine learning, it's almost less deterministic than with software engineering. You don't quite know what you're going to get. And so you need to really optimize for many more at-bats where you can deploy or where you can implement a new feature, train a new model, see if it kind of looks good when you backtest it. But for these production models, you really need to throw it out into production to see how it really fares when it sees the real world. And what are the second or third order effects? Like, maybe you say Uber changing the ETAs now with a model. How does that now actually affect a rider behavior and a driver behavior? That's not something that you can test by running a back test, unless you've got some really nice simulation systems. And so that's really what we wanted to optimize for. Bring this iteration cycle down to make it possible to really rapidly experiment and test and throw new ML models out there as easily as you can develop new software applications and get them into production.
I guess were there any learnings along the way with that too, in terms of maybe the best way to deploy machine learning models? Walk me through that sense of discovery. I mean, you bring up the word deterministic when you're talking about software deployments, and machine learning definitely seems more probabilistic in a lot of ways. But there's also, as you say, second, third order effects where even introducing a model over here is probably going to have an effect over here on this other model, and so forth. I mean, what were some of the what was the progression like from when you first started out to when you were, let's see, maybe a bit more dialed?
Yeah. Let's see, a couple of things that come to mind. One was initially the system was much more batch model focused, and initially we were even thinking, hey, Michelangelo and ML at Uber will probably be more interesting for batch only use cases, like your offline churn prediction that determines what types of promo codes are you going to send out to folks, or sales forecasts and stuff like that. And real-time applications like ETA predictions or fraud predictions may just make up a small minority of use cases. And that's one thing where we realized over time, hey, this system is actually much more powerful and much more interesting for these real-time use cases, where we expected 80% batch and 20% real-time, and later on found, hey, it's exactly the inverse, where we've got 80% real-time and 20% batch. And a couple of other things that we realized were, one, like typically data scientists and engineers, they love to have freedom of choice, right? Like, what are the tools that you want to use to train your model? What are the latest frameworks and gimmicks and libraries and environments that you want to use? Because maybe you use them with your previous employer, and so you can already hit the ground running. You know what you're doing. And oftentimes folks don't want to let go of that and use something standardized. But with something like Michelangelo, there was a real big carrot here, which was, hey, if you use the standardized, centralized platform, then yes, you cannot do everything exactly the same way anymore as beforehand. There is some standardization here, but you're going to be 1,000 times more productive and more efficient beforehand. And it's going to be much more rewarding for you to see your new features and your new model in production within a couple of hours, rather than only getting the short-term satisfaction of using exactly the tools you're already used to, but then having to wait half a year until somebody actually productionizes it. And then you find out, hey, they actually didn't productionize it the right way, and they treat nulls a little bit differently than you intended them to treat them. And so that was one thing that was interesting to observe, just how people were then actually, at the end of the day, fine to let go of some of this freedom and standardizing their workflows in order to get this rapid life cycle of model development and deployment going.
Interesting. And then you started Tecton, and I guess what's the translation like from coming to Uber with a framework that worked at Uber, and then trying to translate that into a framework that might work for the rest of the world?
Yeah, that one's really interesting, because one thing that we were initially quite closely looking at is the data ecosystems and the infrastructures of different companies are extremely diverse. And so the question is always, okay, can you build a standardized platform that actually generalizes across different companies and their different infrastructures and stacks? And that's, for instance, also one reason why you haven't seen an open source version of Michelangelo yet. It's just very deeply integrated and coupled with the existing infrastructure. Then it would be hard to rip it all out and generalize it. It would be easier today than it was 5 years ago, but it's still not super trivial. And that's one thing that we thought about a lot. And what helped us here a lot is where a lot of the trends in the data ecosystem. Obviously, a lot of enterprises were rapidly adopting the cloud. So that's great, because now you suddenly don't have to deal with all these different old school on-prem technologies anymore, because a lot of the cloud native enterprises, or at least the ones that have been moving to the cloud, they're now using the cloud-centric primitives around data lake, around the data warehouse, around online stores, around data pipeline systems. So that allowed us to build a system on a fairly consolidated data stack. There's still a variety here. Like, there's still some companies who prefer Delta Lake or just native naked S3, and others really love Snowflake, and others really love Redshift. And then on the streaming side, some companies really love Kafka, and others really love the simplicity of Kinesis, despite its shortcomings. But it's a manageable set of technologies now that you can build really first-class connectors for, without drowning in a ton of work of having to integrate with 1,000 different on-prem technologies. And that is a trend that definitely played in our favor, and that made it possible for us to take what we learned at Uber and take a lot of the blueprints and the lessons learned around how to build a really, really scalable system, and now generalize it by building it on top of these cloud-native data primitives that are proven to scale, and that a lot of modern enterprises are already choosing to use as part of their data stack.
Interesting. You mentioned like cloud primitives. Are there any other types of primitives that you find kind of common throughout, I guess, different companies that you talk to?
I mean, it's what are the best dimensions to slice this by? I already mentioned the different streaming systems where companies are either consolidating around Kafka or around Kinesis. When it comes to large scale offline stores, they're either consolidating around a data warehouse or a data lake. When it comes to your data science environment, they're either consolidating around an end-to-end type system like your SageMaker, or they prefer to really run their own Jupyter notebooks on top of like a Kubeflow or something like that. And then there's a lot of different tools I could look at that are pretty much used by most modern enterprises, but that will be a pretty long list now too, so I don't know how to best break it up.
Yeah, that's interesting. What's it been like so far? I mean, you guys came on my radar last year, Tecton, when you made your, I guess, came out of stealth. That was pretty cool to see. I think I hit up Mike almost immediately and just wanted to chat, kind of just understand like where are you guys going with this company? It seems really cool. And I think it also sort of coincided with the popularization of the feature store. And it seems like you can't go anywhere these days without hearing about feature stores. So for the audience out there, what is a feature store?
Sure. A feature store is really a data platform that solves the data problems around machine learning. And let's make this a little bit more concrete, which is when you train a model on top of data, and specifically you train it against a set of features. So let's say you want to train a fraud detection model, like a credit card processor, a bank wants to detect fraud. And an incoming transaction contains information around the source credit card, the, say, IP address, maybe the GPS coordinates, the merchant, the transaction amount, like a lot of this raw data. And as a data scientist, you're tasked with turning this raw data into a model that can detect fraud against a new incoming transaction that it's never seen before. And so the data scientist now tries to figure out what are some features, some signals that I can pull out of this raw data that may allow the model to predict fraud. And that could be things like, how often have I seen this merchant before? How frequently has this user used this credit card in this geohash beforehand? How many transactions has this user committed over the last 30 minutes with this transaction? How many have they committed over the last 30 days? What categories does this user typically purchase items from to begin with? Like, those are all derived signals from a large set of transactions that a user or different groups of users have made over the last years or over the last seconds. Like, all these different signals matter. And as a data scientist, you want to turn this raw data into these features so your model can pick up these signals, and then later on in production, use these features derived off of an incoming new transaction to predict whether it's a fraudulent transaction or not. So that's high level. What are features, and what does a data scientist do in order to get raw data translated into features to get a training data set? And what a feature store does is it gives a data scientist or a data engineer or an ML engineer the ability to develop features where they would, say, write some SQL statements or some PySpark code or some Python code that turn raw data into features. And then it allows the data scientist to generate and fetch historical data from the feature store, where they say, oh, for a given user, at any given point of time in the past, how many transactions has this user made at that point of time in the past? And so you can generate now your gigantic training data set, merge in a column, a label column that indicates whether this was a fraudulent transaction or not, and then you train your model. And then in production, you would go to the feature store by just calling a REST endpoint and say, hey, for this given user and this given credit card, what is the rolling transaction count as of right now over the last 5 minutes? What is the rolling transaction count over the last 30 minutes? How many times has this merchant ever been seen in the last 5 seconds? And so you can go to the feature store and fetch these type of features in a couple of milliseconds to then predict whether it's a fraudulent transaction or not. So that's what the feature store does. Turns raw data into features and then serves those features offline for training purposes and online for prediction purposes. And then, of course, it also monitors the data. It tells you when there is data drift, and it allows data scientists to just develop a feature once centrally and then share it with the rest of their teammates or the rest of the company.
What type of data is most appropriate for, I guess, a current generation of feature stores?
Structured data, typically.
Okay.
It's all around data that you can somehow either structured or semi-structured, which you can then turn into columnar derivatives that you can feed into your model. That's typically what a feature store is best suited for.
When I was listening to you describe the feature store as well, I kept noticing there's an element of time involved.
Yeah.
Is that pretty key as well?
Yes. Yeah. Great point. So time is key because there is a huge problem in machine learning that's super hard to debug and extremely costly, which is called train, serve, skew. And what that means is that you show to your model at training time data that it would like that never see in the real world when you make predictions. And that could happen if, say, you're calculating your features actually one way offline and another way online, where, say, offline you fill in nulls with the average and online you fill in nulls with a 0. That would be a form of train serve skew. Another very common form is data leakage, where you're now leaking data from the future into the present. And so, for instance, imagine you want to predict the traffic situation on like how long it's going to take to travel from San Francisco to Palo Alto. If you look at a ton of historical trips, one feature maybe, was there an accident on this trip or not? And if you have this data point, then of course it's pretty easy to predict how long it's going to take to travel from San Francisco to Palo Alto, because there's an accident, so it's going to take longer. Easy for the model to figure out. And you get a fantastic model, it backtests well. But in production, you'll realize that it just doesn't perform well at all because it cannot look into the future. It cannot know whether an accident will happen. It maybe has some data from the past, how likely it will happen, but it would never know exactly whether on this trip an accident is going to happen. And so this is where the time component comes in. That's super important, where a feature store provides what's called time travel, where it allows the data scientist to look at feature values from any given point of time in the past, and it guarantees that no data from the future is being leaked in. So you couldn't implement with a good feature store a feature that would capture information around whether there was an accident on a certain route and a certain trip in the past.
That's really cool, and does solve a huge problem that I've seen in ML, where you try and predict on a data set that is just basically, it's just wrong. It doesn't represent reality at all. But it's really common, though, and I think it's easy for data scientists to accidentally do this without even being aware that it's happening. And
exactly, that's the biggest thing. And it's so hard to debug later on. It's so hard to figure out why your model is not performing as well as it did when you trained the model to begin with, and because there is no like hard constraint that you can put in place without a feature store that would really avoid introducing some sort of data leakage.
Interesting. Would there ever be a consideration for using like maybe unstructured or feature stores with unstructured data at some point? Images or video or audio?
Yeah, so one thing that we do support and we have some use cases for is typically when you have derivatives of fully unstructured data. So you could, for instance, say you could scan some text with some NLP models and turn that into embeddings. And now embeddings, turns out, are at the end of the day vectors and arrays that you can store in a structured format in the form of a feature in a feature store. And in that way, a feature store actually does make a ton of sense, where you now really store the structured representation, which is a derivative, a structured human non-interpretable derivative of fully unstructured data. And then you serve it the same way offline without introducing data leakage, and you serve it online at the scale and the latency that you're used to. And Uber Eats, for instance, makes heavy usage of that for restaurant recommendation use cases.
Interesting. For my own education, and probably for the audience too, like there's a bunch of feature stores coming out. AWS just released theirs. There's Feast. There's Tecton. I mean, what's the difference between all these? And there's probably more that I haven't heard of, but yeah, those are the big ones that come to mind.
Yeah, so Feast is actually part of Tecton too. So we're the main company developing Feast since Willem, the original creator, decided to join us last year. And Feast is really an open source feature store, which is not managed in contrast to Tecton. Tecton is fully managed and it's proprietary software, and we host it for you either in your cloud or in our cloud. So that's a big difference: managed versus unmanaged, open source versus not open source. And then on the capability side, Feast is very focused on ingesting pre-computed feature values. So you run the streaming pipeline yourself, you run the batch pipeline yourself, and then you just ingest those feature values into Feast, into his offline store and online store, to then serve it for training purposes or for serving purposes online. But Feast doesn't help you manage and run your batch pipeline or manage and run your streaming pipeline. Tecton does all of that, and then Tecton also runs on-demand transformations for you, which are actually real-time transformations, where at request time you turn some raw data into a feature vector without it having to ever pass through a streaming system or through a data lake or a data warehouse. For instance, if you have, again, a fraud detection model which turns a geolocation into a geohash, that will be a feature transformation that you want to execute on demand at request time, because it would be absurdly expensive to pre-compute this typically for our
right. That's really cool. MLOps, that's another big term that's being thrown around right now. What is MLOps to you?
MLOps, in short, to me, is bringing the best DevOps practices to the development and deployment of machine learning. And what that means, if we drill in a little bit, is with DevOps, as I described super early on in this conversation, it makes it super easy to change a line of code and then deploy it fully autonomously, test it, build a Docker container, throw it over to Kubernetes to deploy it. So that's fantastic. We want to get to the exact same place with machine learning by using and introducing an integrated MLOps system, where as a data scientist, you may just change, say, one line of code in your model training script, or you may want to change one line of code in your feature transformation, or you may want to add one more feature to your end-to-end model. And whenever you want to make one of those, when you want to introduce one of those changes, MLOps should take care of all the rest. It should take care of now spinning up new data pipelines for your new feature transformations. It should automatically then schedule your model training script to make sure that once enough data has been captured and backfilled, you can train your model. It should automatically take your model and deploy it to production. It should version your model as well. And everything, basically this entire downstream set of steps that are required to train a model and deploy it and then monitor it, all of that should happen fully automatically with MLOps, the exact same way that the deployment process of software is happening today with DevOps. And one thing that's fascinating to me there is that when you look at software, there's really just one artifact that you're dealing with, which is your software binary or your Docker container that comes out of it. With MLOps and machine learning as a whole, you really deal with multiple different artifacts. One is still the artifact of code, which trains your ML model. Two is the artifact of your of the data pipelines that produce features and the training data sets that come out of it. And then three is the artifact of your model, the actually trained model that you're putting into production. And you need to be able to develop and version control and govern all of those independently, but then deploy them in a synchronous way, because it's all hanging together. And so MLOps really should make it very easy to develop and version control and deploy and monitor all of these 3 different artifacts together.
Interesting. And we talked earlier, kind of, there's an explosion of, I guess, technologies and options out there right now. I mean, if you're advising somebody who's getting started in MLOps with their company, how would they choose from the vast array of open source options, third-party, proprietary, and also the cloud offerings out there? To me, I'm just horribly confused every time I look at the landscape. I don't know how you feel about it, but it's pretty, it makes you dizzy.
It is, yeah, it's definitely a dizzying platform. So ideally, talk to some people who've gone through the journey beforehand. Ideally, actually jump on the MLOps community Slack channel and ask in the community, hey, like, this is my use case, this is my problem, this is what my stack looks like. What tooling should I use? Because I could give you right now 5 different reference stacks that all would make sense for different companies and different purposes, because it really depends on, are you a heavy build shop where you want to have full control over everything? That probably means you want to build everything on open source and manage it on your own. Are you a company that really wants to purchase software from vendors, so you've got SLAs and guarantees and all that stuff, and you don't have to overload your eng team? That is another dimension. There's a set of vendors to then choose from. Are you a company that's still on-prem or hybrid, or are you fully in the cloud? Another super important dimension. Are your use cases batch only, or do you also have online operational models that depend on streaming features or on these on-demand features that I just described? It's another super important dimension. Also, what stack do you already have? Are you a Databricks customer, or are you a Snowflake customer? That determines pretty heavily what do you use. Are you an R shop or a Python shop? So it's like countless of these dimensions, and it really depends on what you have today. Mm-hmm. Is that still the appropriate choice, or would somebody recommend, hey, you should probably upgrade some of these more fundamental technologies to something else, and then use this reference stack, because that's a future-proof, at least for some time, stack that seems to fit the use cases you have to answer to right now in your business and probably over the next 10 years.
Yeah, that makes a lot of sense. Yeah, it's so hard to figure out, I suppose, because there's different use cases, and also, how would you learn MLOps right now? I mean, I think there's some books coming out, and maybe there's a lot of videos and content, but I mean, it seems like one of those areas too that's still, I think, a bit open-ended. Do you have any suggestions in that area?
MLOps community channel is, again, the main resource.
Okay, yeah, shout out to Demetrios, by the way. Also, exactly. Thanks for making the community.
Exactly. We also want to actually publish a couple reference stacks to make exactly that a little bit easier, where companies can actually come to some sort of a website and say, hey, this is my stack, this is my use case. What do you recommend? And why do you recommend it? Don't just tell me what I do, but explain it to me. And I think you can actually make that fairly structured and guided. We just haven't, sadly, gotten around to it just yet.
It's hard to do, though, right? And it's one of those things, too, I think, because I've seen some of the reference stacks that MLOps communities come out with, I think, for observability and a few other things, feature stores. I think it's great. But it seems like it's definitely like a point-in-time reference, whereas it also seems like the best practices are also still being kind of fleshed out. Because I think back to your original, one of the points we were talking about earlier, like kind of generalizing, the problem space that you saw at Uber, for example, and trying to generalize that to the broader population. It's not easy, right? And I think everyone's coming to these solutions from maybe their past experience at other companies, and then trying to translate that into something that's generally available. But that's hard. It's really hard.
It is. Yeah.
That's interesting. Where do you think this all goes in the next 5 years? I mean, I want to get, maybe it's prediction time, but like, what's the future of the data and ML space, do you think, over maybe the next few years?
Yeah, for sure. I think on the one side, this problem that we just discussed, I think is going to be made much easier, where people finally will have a navigatable landscape that maps pretty concretely their use cases now and in the future to a stack and a set of vendors that they should choose from. As a result of that, I'm also pretty sure that we'll have much deeper integrations between the key vendors out there, from the feature store, obviously, to training systems, to deployment systems like Selden and Algorithmia, to ML monitoring systems like our friends at Arise. And so you'll see, I think, a lot of these individual integrations happening between the vendors. And all these vendors, I think, are going to focus on being the best of breed player in their domain. And then you purchase 3-4 of those, they integrate really nicely, and then you've got your end-to-end ML ops platform. But on every single one of these steps, you can still choose to replace one vendor with another, and they'll be integrating against standardized interfaces, which then actually makes it possible to swap out your training vendor A for training vendor B. And as a result of that integration now, I'm pretty sure we will be going to this place that I just discussed earlier around the holy grail of MLOps, where you change a line of code in your feature or your model training code or anywhere else, and the whole machinery is going to be automatically kicked off around deploying your ML model. And later on, you can always go back and take a look at which model was deployed, when and where and why, what was the exact code that was used for a feature, what was the exact code that was used for the model, who trained the model to begin with, did that user have the actual permission to use certain data for a certain use case, what were the predictions that were made. And so you'll have full lineage and full governance in this entire system then as well. And now, next step, taking MLOps and bringing it back to the whole of data, I think where we need to go to is have basically the way I envision that is having a central mega DAG in a company that you can look at, and it's this gigantic web of different data pipelines and different data stores and data sources and ML models and consuming applications that are making predictions. And you can look at this entire beautiful DAG, and you'll be able to just zoom into individual aspects, and you see, hey, what's green, what's red, what's orange, and why is it? And then you can zoom in and maybe retry something or debug what's going on, but you'll have this end-to-end connected DAG of data pipelines, model pipelines, prediction systems, consuming applications that all follows the same standardized rules around governance and version control and access controls and everything else that matters for the enterprise.
That's a really interesting thought. One thing I've been thinking about a lot lately is there's a distinction between data engineering and ML engineering. I think part of me thinks this is a bit artificial, especially when you bring up this notion of a mega DAG, and it seems to cross the boundaries between whatever a data engineer does and an ML engineer does. I'd like to get your thoughts on this. Do you feel like there's maybe a dichotomy between data engineering and ML engineering? And is it justified?
Yeah, it's definitely a fuzzy line. I think an ML engineer is typically somebody who has to have additional knowledge about the ML domain because they need to understand concepts like data drift and data leakage, all of the train serves queue issues that we discussed earlier. They need to be well-versed not just in how do I productionize a data pipeline against a streaming system and a batch system, but also how do I train a production-ready ML model? How do I hook it up to monitoring and observability systems? And so it's, to me, a superset of the data that what we could today consider the data engineer's area of responsibility. And realistically, probably will see many data engineers be able to use the tools around MLOps to then really be an ML engineer. And that's one goal, for instance, that we have as well here with Tecton, is that a feature store like Tecton enables data engineers to really be ML engineers.
Mm-hmm. It seems like it. Yeah. I mean, I've been toying with this idea, and I don't really see that much of a gap, honestly, especially with the way the tooling is becoming a lot simpler to use, and I think a lot more accessible.
Yeah.
It's gonna be interesting to see. Kind of taking a different tack here. I mean, so you've done companies since you were in high school. I think you've been pretty successful at that. What advice do you have for founders and technical founders of companies?
For technical founders of companies, it definitely depends on the stage. But the biggest one probably for the technical founders is don't let perfect be the enemy of good enough, right? Like as engineers, we oftentimes have this desire to prematurely optimize things and make them perfect right from the get-go, just because it's so much fun to be creative as an engineer and implement things as as perfectly as possible, introduce as many abstractions as possible, make it as efficient as possible, while you kind of lose sight of what does the customer actually want, what is actually their problem. And so really subscribing to the rapid iteration MVP mindset and philosophy around company building, especially for super technical founders, is, I think, extremely important. And outside of that, I think if you are a technical founder, either partner up with somebody who's not fully technical and has some of the other non-technical skills too, or yourself, like pick up other skills around how are you going to be able to be a really effective communicator, a really effective writer, have a basic understanding of finance, of fundraising, of marketing, of sales in general. Like there's so many other dimensions that are quite important, and that I think somebody with a technical analytical mindset can pick up, but you have to invest some time and learn about it, unless you partner up with some other founder who's got some of these skills already.
Interesting. So sort of somebody who's going to complement the left brain, I suppose.
Yeah, exactly.
Yeah, I mean, I'm looking at your experience is pretty interesting. I mean, it looks like you got an MBA and did a bunch of I would say non CTO-ish type stuff, but I think that's really cool. And what drove you to? I mean, because I think the natural tendency for a technical founder is just to stay technical and not focus on the business. That's the business guy's job. I mean, what drove you to, I think, become a bit more, I would say, well-rounded?
Yeah, really, on the one side, the deep passion for tech entrepreneurship. I just love that stuff so much, always have and probably always will. And the realization with this first company that I had after high school and the failures around it, that just being good at technical things alone is not enough, and I need to be more well-rounded. And so what's the best way to pick this up? I thought, okay, let's go to business school, get an MBA, hang out with other entrepreneurs, talk to some professors who know this stuff well, and learn a bunch of things about the business side of things and be more well-rounded in that respect. So that's really what drove that. And then also just some curiosity. Like I get bored if I only dig into one specific area and only learn about coding, and I'm only coding all day long. Like I need some variety in my day-to-day job and the different types of problems that I solve. And so that was another great way to expose myself to a huge diversity of problems that I get to work on every day.
Do you find that helps you, I guess, in your role now at Tecton, just having that kind of variety of experiences?
I believe so. I don't have the counterfactual, right?
Right.
But I think I oftentimes dip into different things that I either learned at business school or books that I read or people who I've chatted with about very, very non-technical things.
What books are you into right now?
One book that I'm reading right now is David Deutsch's The Beginning of Infinity.
Oh, I started reading that too.
Oh, yeah?
Yeah, it's really good.
Yeah, it's very good. It's a very dense read. But I've enjoyed it a lot. The story of philosophy is pretty good too. I've enjoyed it a lot.
Interesting. Check that out.
All of Yuval Harari's books are exceptional that I've really enjoyed as well. So it's really from a wide variety of different disciplines.
Yeah, I'm the same way. I find that like wide reading, I think it tends to help in like weird circuitous ways that don't make any sense at the time.
Yeah.
But then I think by just molding your brain in sort of I guess a non-linear way is probably good, especially these days when you have to. I think with the rapid pace in technology, it definitely helps to have very unorthodox views on how the world works, how to approach problems. Because if you try and approach it just like everybody else would, you're going to get the same results everybody else does.
Yeah. And it's so much more boring too.
It's so boring. What do you do outside of work then? Like, do you have any hobbies or?
I do, yeah. The biggest thing outside of work that I spend lots of time outside of work on is triathlons and
no way.
Long distance races in general. Yeah, so I love ultra marathons and long distance triathlons and just getting ideally better at it every single day. And it's a lot of fun because it allows you to really measure yourself, and it's brutally honest, right? You're seeing from week to week, from month to month, are you getting better? Are you getting faster? Are you getting slower? And I love that about it, and love the long distance aspect about it too, where sometimes you just got to push through for 10 hours or for multiple days at a time and not lose your mind over it, and build up some grit and stamina to just push through, which I think helps me in the startup world as well.
Oh yeah, I could see that for sure. It is good mental training. What kind of ultras do you do? Do you like road or trail or?
Actually, trail. One that I
Nice.
did 2 years ago was the Marathon des Abilis in the desert in Morocco, where you run like for 150 miles through the desert and with a bunch
That's
of other
insane.
people. It's actually really cool where you're supposed to be mostly self-sufficient except for water, and so you pack all your own clothing and food that you're gonna eat over the days and run with it in your backpack. And it's actually a really, really fun, almost like adventure race, and it builds an incredible sense of camaraderie where there's a bunch of other people who you're hanging out with who are in the same boat, and we're still actually really, really close friends with many of the people who were part of my little tent there.
I'm sure. Yeah. I mean, that kind of like shared suffering is probably, and shared adventure is like something that
Exactly.
brings people together quite a bit. Yeah, that's awesome. Ultras are good. My wife does those. Actually, I'm not a long distance person. I did a Spartan Beast over the weekend, and it was just like that was like the worst course I think I could have possibly imagined. I was up at this ski resort, but it was just so gnarly. I was like, I'm so done with this stuff. So
Are you gonna do it again?
I don't know. Get back to me after the after my frustrations worn off.
Is your wife not pulling you in the whole time and taking you to some of those races?
No, she ran it with me, and she can do that stuff off the couch. It was like I think 4,000 or 5,000 feet in gain, but it was just really hot the entire time. I was just like, God, this is horrible.
Yeah.
But that's awesome, man. Hats off to you, and the ultras are no joke. We have actually, I think next month, her brother's running the Wasatch 100 in Salt Lake, just here. So it's a 100-mile race in the mountains here. Yeah, it looks fun for you.
It's exciting stuff, man. I love it.
You got any races coming up?
Yeah, I'm doing a half Ironman in St. George, Utah.
Really? Nice.
End of September. So I'm looking forward to that one. That's what I'm mostly training for right now. And then the CIM marathon in Sacramento end of the year.
Dang. That's awesome, man. I don't know how it's a lot of dedication though, right? I mean, to train for these types of races,
it definitely takes several hours a week, but it's it provides some mental sanity too and some balance outside of work and whatnot. And I just really, really love it.
That's a great way to unplug. Well, awesome, man. Well, I guess it's a good place to wrap up. But for people who want to find out more about you and Tecton, how would they do that?
Yeah, come check out Tecton.ai. We also have a Feast and Tecton shared Slack channel where you can find us, or you can find us in the MLOps community, or just shoot me an email at kevin@tecton.ai.
Awesome. Kevin, it's been a lot of fun talking to you. So
likewise.
Awesome. And best of luck with Tecton. Really big fan. So hope you guys do great.
Awesome. Thanks, Joe.
Thanks. Thank you.